Hello and welcome to today's lesson on graphical representations of waves. In today's lesson, we will examine the different features of a wave diagram. So far, you have become familiar with classifying transverse and longitudinal waves. You understand that transverse waves have oscillations perpendicular to the direction of wave travel, while longitudinal waves have oscillations parallel to the direction of wave travel. We will now take a closer look at how we can represent a transverse wave using diagrams. Waves can be represented graphically using a wave diagram, which helps us visualize their behavior and properties. Shown here is a displacement versus time graph of a transverse wave. By examining this diagram, we can easily identify different features that characterize the wave. There are 5 main features, starting with the crest or peak. The crest, also known as the peak, is the highest point on the wave diagram. It represents the maximum positive displacement of the wave from its equilibrium position. In other words, it is the point where the wave reaches its furthest height above the equilibrium line. Next is the trough. In contrast to the crest, the trough is the lowest point on the wave diagram. It signifies the maximum negative displacement of the wave, representing the point where the wave dips furthest below the equilibrium line. Then we have the equilibrium line, which is a horizontal line that represents the wave's undisturbed or resting position. It is the baseline from which all displacements, both positive and negative, are measured. Next, we have the amplitude of a wave. This is defined as the maximum displacement of a point on the wave from its equilibrium position. It measures the wave's strength or intensity and is calculated from the equilibrium line to either a crest or a trough. For instance, if the equilibrium line is at 0 and the crest reaches +2 units, then the trough will be symmetrical at -2 units, making the amplitude 2 units. Finally, we have the wavelength of a wave, which is the distance from a point on one wave to the equivalent point on the adjacent wave. It is usually measured as the distance between 2 successive crests, or troughs, but can be measured between any 2 successive equivalent points. The wavelength is often denoted as lambda. It tells us how far the wave travels before it repeats its shape, and is a crucial descriptor of a wave, as we'll discover more in later lessons. Understanding these features of a wave graphically helps us interpret and analyze the behavior and properties of waves. Along with displacement time graphs, we also have displacement distance graphs. While this graph tells us something slightly different from a displacement time graph, namely how far the wave travels, it has the same features we outlined earlier, such as crests, wavelength, amplitude, and troughs. In today's lesson, we focused on understanding the main features of a wave graphically. We started by learning how waves can be represented using wave diagrams, which helps us visualize their behavior and properties. We then discussed key features of a wave, including the crest or peak, which represents the highest point of maximum positive displacement, and the trough, which is the lowest point of maximum negative displacement. We also covered the equilibrium line, showing the undisturbed position of the wave, and the amplitude, which measures the maximum displacement from the equilibrium line. Lastly, we examined the wavelength, the distance between equivalent points on consecutive waves, such as the distance between 2 crests or troughs. This graphical approach allows us to visualize the movement of energy and the characteristics of waves, aiding in the analysis of wave properties in various physical contexts. Watch the rest of the GCSE physics course at Sophos Education.